Okay, folks, here is, where are we? There we go. Number 14. Here's number 14 on your practice final question here. Notice you've got a subtraction of fractions, whether you're adding or subtracting fractions. The rule is you must have a common denominator, and we do not. So we need to find that first, all right? So to get these denominators to be the same, think along the lines of factors. What can I multiply against one or both of the fractions in order to get them to be the same? Notice if I took this 5x and I multiplied it top and bottom by 5, I would end up with 25x. Then to make this a 25x, I would have to multiply it top and bottom by x. 25x, 25x. Both fractions now have a common denominator of 25x. That's how you do it. Okay. The numerators change slightly. You've got x times negative 4, and then over here 3 times 5. Now you're ready to put your numerators together, negative 4x minus 15 over the common denominator of 25x. If you go over and take a look here, there it is right there, right off the bat, choice A. Okay, now here's number 15. All right, notice it says find the intercepts for the graph of the equation. Here's the equation. And notice this time it gives us the intercepts already in xy form, in coordinate point form. So that's how you're going to come up with your answers in the end, but it's already there for us. Let's find first. Find your intercepts. Doesn't matter which one you find first. But let's find. Let's say we find the y-intercept first, which means we're going to set x equal to 0. Then we'll come back to find the x-intercept. We'll set y equal to 0. Okay. So the first one here, we're going to find the y-intercept by plugging 0 in for x, and here's what it looks like: negative 3 times 0 instead of x plus y equals 9. Anything times 0 just gives you 0, so you're left with y equals 9. So when x was 0, that's what we let x be in this part, we find that y is equal to 9. Let's take a look. Remember, it's multiple choice. There's your y-intercept as a part of choice A, 0, 9. Notice something else, folks. 0, 9 does not show itself in any of the other three answers, which means by default, A must be your answer. You could click A right now and move on. Save yourself time for something else that's more pressing, or other problems that you have more of an issue with. Now, just for the sake of argument, and we'll do it on this video, we'll find the x-intercept too, which means we plug in 0 for y now, and now solve it for x. And you'll see that when you divide both sides by negative 3, you end up with x equals negative 3. That's your x value when the y value was 0. So if you go back over, there it is, choice A, negative 3, 0. But you could save yourself time since none of the other three answers had 0, 9 in it. And by the way, if you found the x-intercept first and you found negative 3, 0, you'd see the same thing. The other three choices don't have that, so it has to be choice A. Number 16. Notice, folks, it's a division problem. In the denominator, you have a binomial, two terms. The best way to handle this is either by way of long division or synthetic division. Okay, we'll do both ways. Here's the long division already set up for you, and I want you to notice something. This is where that missing powers that you learned in this class and in Math 017, if you took it, this is where it becomes important. If we're going to perform this division, we need every single power represented, because it might come up within our answer that we need to represent, or we'll have these powers as we go through our solution. So you need to represent them. There's no x to the second, put a 0 in front. There's no x to the first, put a 0 in front. And then you have no x at all, which is represented by the constant number 27. Now, to do the division, you take the first term in the binomial or the first term in the divisor and divide it into the first term in the dividend. So this is what you're trying to do. Simplify x third divided by x, which just gives you x to the second power. That's step 1. Step 2, take that first term of your quotient and multiply it back against multiply it back against both of the terms in your dividend. X squared times x, you should end up with the exact same thing. And then x squared times 3, which is 3x squared. Step 3, subtract this newly found binomial by changing its signs. So they both become negatives. And what should happen is these should cancel out, and they do. Over here, 0 minus 3 is negative 3x squared. Bring down the next term, which is 0x, and do it all over again. How many x's fit into negative 3x squared? So this is what you're trying to figure out. Simplify this fraction. It's going to be a negative, all right? And the x squared over the x cancels out to just x. The 3 stays, and there's what you end up with. Now take that negative 3x and multiply it back against both of the terms in the divisor. Negative 3 times x is negative 3x squared. Negative 3 times a positive 3 is a negative 9x. Step 3, subtract, which means change signs. They both become positive. These cancel out. I'm left with a positive 9x. Bring down the next term, which is a 27. And again, one more time, let's divide. X goes into 9x. How many times? 9x divided by x. The x's cancel out. I'm left with simply a positive 9. Distribute that 9 back through. 9 times x and 9 times 3. Finally, step number 3, change signs because you're subtracting here. They both become negatives, and look what happens to both. These should cancel out, but so do these, leaving you with a remainder of 0. And there's your final answer up at the top there, x squared minus 3x plus 9. Now let's say you wanted to go the synthetic division way. Okay, remember, the number that goes out here is not the 3. You got to remember what this actually is. If you take the x plus 3, set it equal to 0, you end up with the x value of negative 3. So out here goes your x. Your x is a negative 3, not a positive 3. All right, here it is right here. We just proved that x is a negative 3 by solving this. Inside go the coefficients of the polynomial of the dividend, okay, or the polynomial that is the dividend. And again, this is where your missing powers come in very important. You've got a 1 for this coefficient, a 0, a 0, a 27. So we put those 4 numbers across the top here. Now remember, we add vertically and we multiply the sum back against this negative 3. So we start out by adding. 1 plus 0 is 1. We take the 1, multiply it by the negative 3. There we go. Add again. 0 minus 3 is negative 3. Take that, multiply it against the negative 3, you get 9. Add again. 0 plus 9. Take that, multiply it against the negative 3, you get negative 27. Add again. Remember, folks, the number you end up right here is the remainder. All right? And these 3 will represent the coefficients for the quotient. Again, when you use synthetic division, remember, you start with x to the third. The first term in your answer is 1 power less. So this 1 goes in front of x squared. This negative 3 goes in front of x to the first. And that 9 is the constant. And you can see same exact answer. Going back over here, notice you got a multiple choice for this. What was that? I forgot it that fast. X squared minus 3x plus 9. Okay, there it is. All right, x squared minus 3x plus 9. Notice the answer right above only differs with a sign right there. Be careful. All right, you might choose that one. I can't give you any credit for that in the end. It's a multiple choice. You know, I mean, if you just misclicked, you've got to be careful with that. There's no reason to misclick like that. Just be careful and click D. Okay, number 17. Find the numerical values of, and they give you the expression right there, for the given values of x. Folks, all that means is evaluate. They could have summed this up by saying evaluate, give the expression when x is 4, right? And then do it again when x is negative 4. That's what we're going to do. We're going to evaluate twice. First, we're going to plug 4 into the expression everywhere we see x. So we're just rewriting at this point. Down the bottom, you got 2 times 4 plus 8. And now notice the x is gone. Now it's just a matter of cranking it out arithmetically. Up top you got negative 4 squared. That's a negative 20. Sorry, negative 5 times 4. Reading ahead. Negative 5 times 4 is a negative 20. We're going to end up squaring that. Down the bottom you got 2 times 4, which is 8, plus another 8. That's going to give you 16 down there. Up top you got negative 20 squared. That's negative 20 times negative 20. That's a positive 400. Okay, so you got to do a little bit of a division here. Little division problem. How many times does 16 go into 400? Well, 16 goes into 40 twice with a remainder of 8, and you bring down to 0. Think of 4 16s. That gives you 64, right? 16 times 4 gives you 64. If you add one more 16, a fifth, you end up exactly at 80. So 5 times 16 is 80. So when you go over to answer this on your test here, you first have to choose radio button A, and then click inside the box and type the number 25. Now we plug in negative 4. Now we plug in negative 4 for x. So I have negative 5 times negative 4, that squared. In the bottom I got 2 times negative 4 plus 8. And we crank this out. Up top, negative 5 times negative 4 is a positive 20. Down the bottom, 2 times negative 4 is a negative 8, and you might start seeing what's going to happen right here. Doesn't really matter what we have up top, which is a 400, because on the bottom, look what you get. Anything added to its opposite cancels out. Cannot have zeros in the denominator, so when x is negative 4, you want to click radio button B, because you end up with a 0 in the denominator, which is an undefined value. Be very careful with that. Okay, number 18 here. Find an equation of the line containing the given pair of points. Here they are. Express your answer in the form x equals a, y equals b, or slope-intercept form. And don't be confused by these two forms, folks. X equals a, meaning x equals some number, is the equation you have when you have a vertical line. And y equals b is what you have when you have a, or y equals some number, is the equation you have when you have a horizontal line. Otherwise, it's in this form, y equals mx plus b. So we're given 2 points. Let's first find the slope. Let's label these points. All right, and here's our formula for the slope. X2 minus x1 in the denominator. So now we just plug the numbers in. 7 minus y1, which is y2 for the 7, minus y1, which is 0. In the denominator, you have x2 minus x1. And you end up with a slope in simplified form of 7/4. Now, we have a point. In fact, we have 2 of them. You choose. And we have a slope. We have a point and we have a slope. Point, slope. Use the point slope formula. There it is. Plug in. And it doesn't matter which point you use. I'm deliberately going to use the zeros because they're easier. Y minus the y value of 0 equals the slope of 7/4 times x minus the x value of 0. Okay. And by the way, if you plugged in 4 for x and 7 for y, you'll get the same answer no matter what. Look what you have over here on the left side of the equation. You just have y. It's already solved. And over here in the parentheses, you just have x. So it's 7/4 times x. There's your equation. Now, when you go to enter this equation, be careful. The y equals is already there. So you don't want to write y equals again. It's already there for you. That might end up getting it marked wrong because the computer might not be expecting that. Should be, but you never know. We don't know what the coding looks like behind the scenes here. All right. So y equals, all you have to plug in is this part. After the equal sign, 7/4 x, which means you need to hit, you should be able to see it on this video now, you need to hit that fraction button first, then click in the numerator, type 7, click in the denominator, type 4, arrow to the right, don't spacebar, I don't think that'll get you out of it. That'll just keep your cursor down here in the denominator waiting for you to hit another key. Arrow to the right to get you out of that button and have your cursor go back to writing normal, then type your x, and you'll be done. Okay, so here's number 19, folks. Excuse me. Graph the linear equation, x equals y plus 2. So here it is over on the whiteboard. notice all I have to do is subtract 2 from both sides, and it's automatically put into y equals mx plus b form. Now, it's written opposite the way you would like to see it, but it's still the same. Y equals x minus 2. So the slope is right there. You don't see a number in front of the x, but you know that there is a number there. It's a 1, which means the slope, if you were to talk about it in terms of rise over run, it's rise 1, run 1. And the y-intercept is right there, and that would be negative 2. So look how they want you to actually graph this one. This is not multiple choice. So you're probably guaranteed to get at least one problem like this on the test. What you would do is you grab this little button right here. Click this button because you're going to graph a straight line. Then you put your mouse, as you hover your mouse around the grid, you'll see, I can't do it here because this isn't live on the application, but you'll drag your mouse around and the little circle will drag itself to each grid line. It won't stop anywhere in between, so you drag it right over negative 2 and it'll sit right there. Then you click the mouse. Then it's going to wait for you to click the mouse on the next point that you want to lay down, and it'll automatically connect those 2 points with the line. So here's where you hit the first button. That's negative 2, right? That's the y-intercept. Click it there. Then rise 1, and then run 1, and click it again right there, and it'll automatically connect the 2 with the line, and you're done with that problem. And you can make your graph bigger by hitting this little button over here. That way it's a little easier to see than it is right here. It's a little bit small right there, but if you click that, it'll be much easier to see. Here's number 20. Look at this one, folks. It's another absolute value problem. This time it's an absolute value inequality. Okay? But before you even think of going into the setup, this is very similar to one of the problems I gave you on the quiz or the test or both. Look what this says. This says the absolute value of something is less than negative 2. Absolute values, whatever comes out of this side of this left-hand side of the inequality statement, has to be positive or 0. If x was a 0, then 0 would come out. Any other number that comes out has to be a positive number because that's what absolute value means. This says the absolute value of something is going to be less than a negative number. That's an impossibility. Okay, it can't be. It can't be even less than 0. That's an impossibility. Okay, therefore, automatically you go to choice D. No solution for this particular problem here. And again, if you go back to your quiz and test, you'll find on either one of them, I gave you a problem like this where it was not possible. Okay, let's go to the next problem here, number 21. Okay, write the equation, or write an equation slope-intercept form of the line satisfying the given condition. So you want to get your final answer in y equals mx plus b, as all 4 of them are here, slope-intercept form. Okay, so it's a multiple choice, but here's what we got. The point is 2 comma 4. And the rest of the information says it's parallel to 9x plus 4y equals 54. Parallel to this line, 9x plus 4y equals 54. Now, remember something. Let's go back to that little chart we had up earlier. When lines are parallel, their slopes are the same. Their slopes are the same. So here's the line they gave us, 9x plus 4y equals 54. Whatever the slope is of this line, since the line we're looking for is parallel to this line, whatever the slope is for this line is the slope we have for the line that we want. All right, so let's find that first. We have to put it in slope-intercept form to be able to do that. Okay, I can't just look at this and say, oh yeah, I know what the slope is. It's the 9. No. You can look at the number or the coefficient to the x only after it's in slope-intercept form, which means only after it's solved for y. So we bring 9x over to the other side, it becomes negative 9x. And now we have negative 9x plus 54 over here. We're almost solved for y. Now I need to divide all the way through by 4. Notice what you have over here on the left-hand side of the equation, just a y. That's what you want. Here's the slope. Negative divided by a positive is a negative 9/4. There's the x. And we don't even really need to do this right here. 54 over 4 I'm not even in need of that because this is what I want. This is the information I'm trying to get from this problem. What is the slope of this guy? Now that I know what the slope is, I can use that along with the point they gave us, slope and a point, point, slope, point, slope. I can use that information to arrive at the equation of the line, which is what they want for this particular problem. All right, we discover what the slope is. It has to be the same as this line because they said right here, these lines are parallel. So I'm going to use the point slope formula. I'm going to use the y value, which is 4, so it's y minus 4, equals the slope of negative 9/4 times x minus the x value 2. All right, first thing you should do is distribute right here, the negative 9/4. When you do that, you get negative 9/4 x, and that's what it should look like in the end. That's your slope for the line we're looking for. Then it's negative 9/4 times a negative 2. Negative times negative is a positive. All right, 9 times 2, that's going to give you 18 over 4. Okay. And if you go ahead and convert that to a mixed number, it'll make the next and final step a little bit easier. 4 goes into 18 4 times with 2 left over. That's 4.5. Because the final step is to add 4 to both sides, right? In order to get this in slope-intercept form. Cancel out, and there it is, y equals. That's what you want. There's the slope. Negative 9/4 x plus 8.5. Okay? Now, if we go ahead to the other side, here's our final equation. It's already in slope-intercept form. Let's take a look. It's multiple choice. Remember, you can use process of elimination here, folks. Notice the only one of the 4 that has negative 9/4 x, or negative 9/4 for the slope, is B. None of the other 3 have that. This one's close. It's missing the sign, though. Be careful there. So right now, you could say the answer is B, hands down. Don't get worried that you don't see 8.5, because 17 halves is the same thing, right? If I go ahead and make this 18 halves, or I'm sorry, this 8.5, or turn it from a mixed number back into an improper fraction, there it is. 2 times 8 is 16 plus 1, 17 over 2. Okay, so the choice here is going to be B. Okay, here's number 22. Solve the equation. We haven't had many of these, ironically, throughout the whole test, but here's finally one right here. The variable is W, so we want to get the W isolated all by itself on one side of the equation. Let's go ahead and get rid of the parentheses first by distributing on both sides of the equation here. All right, over here 12 times 2W, and then 12 times negative 9 is a negative 108. Over here on the right side, you got 4 times 6W and 4 times 4. You may notice it right here, you may not, that's fine. You have to get all the W's to one side, so let's say I pick these 24 and move them over by subtracting them. I do the same thing to the other side. Look what happens, folks. Whenever this happens, this is a possibility sometimes, right? Where you eliminate the variables completely and you're left with this statement, which is in fact a false statement. Negative 108 never equals 16. What this means is when you eliminate the variables and you end up with a false statement, there's no solution. Now, just on the other side of that, had you eliminated the variables and ended up with a true statement, say like, I don't know, 3 equals 3 or 16 equals 16, that true statement would imply that it's infinite number of solutions. If you look here, all real numbers, that's the infinite number of solutions response, but you want C for this one because we ended up with a false statement right here. All right, that implies that it's no solution for this one. You would click C. Okay, number 23 here. Evaluate the expression when x is 3, y is negative 3, and z is 9. Here's your 3 factors. We're going to plug x, y, and z into this expression. Now notice just a little bit of a look ahead here, folks. Notice choice B says the answer is undefined. Remember, that can only happen for you guys so far when 2 things are present. A denominator where you could have a 0. That's impossible here because your denominator, while 1's not showing, is actually a 1 underneath. So 1 cannot be 0 ever. 1 is always a 1. It's a constant value. The other possibility is when you have an even numbered index, and under that root you can't have a negative number, or a negative value, or a negative expression. Here, we don't have any square roots, or 4th, or 6th, or 8th, or 10th roots, so we don't have to worry about it. It cannot be choice B on this one, but we can still get an answer for A. Make sure, in the end, make sure you click the radio button A before you enter that box. It might not even let you. I'm not sure. It probably won't let you type in that box until you click the A, which is a good thing. That's a good programming thing on your side. So let's plug everything in here. 9 plus X means 9 plus 3. 3 plus Y means 3 plus a negative 3. Just rewriting the expression here. And finally, 6 minus Z means 6 minus 9. Let's go to this middle factor because it might stand out to you right away. A number added to its opposite. You've got in the middle there a factor of 0. So it doesn't even matter what these two factors are, folks. Remember, if one and only one of your factors is a 0, that's all you need. The entire product is 0. I mean, in the end, this is negative 3 and this is 12, but it doesn't matter. 0 is one of the factors. The product has to be 0. So you'd hit the A here, and you would click a 0 inside here and move on to the next problem. Okay, number 24, perform the division. This time, I think it's a little bit easier. All right, you have one single term, a monomial, in the denominator. What you can do to simplify this overall fraction is take that denominator, that term, and write it underneath each of the 3 terms in the numerator. Okay, so when we do that, you've got, let's see, the first one here is negative 24x to the 5th. And we'll put that over that single-termed denominator of negative 8x to the 4th. Then it's subtract from that 24x to the 4th over the same denominator, negative 8x to the 4th. And then it's subtract from that 64x to the 3rd. So let's simplify each of these 3 fractions separately to get to our final answer. And this is a multiple choice question. Yes, it is. Okay. All right, so one fraction at a time. Negative divided by negative is a positive. 24 divided by 8. X to the 5th over x to the 4th reduces to just x. And we have the negative. Here we have a positive 24 divided by a negative 8. That's going to give us a negative 3. 24 divided by 8. And x to the 4th over x to the 4th just cancels out. Then we have a negative again. And a positive divided by a negative, which will be 64 divided by 8, which is 8. And then x to the 3rd over x to the 4th, you end up with 1x down on the bottom. Remember from your third test, that problem where you had m to the 6th, where a lot of you ended up putting the m to the 6th up top when it should have been down the bottom. Same thing here with this problem. In fact, on a different problem on test number 3, you had one that looked just like this. I think it was 6 over x maybe for the final term. Don't forget about these negatives, though. A negative in front of a negative changes to a positive. And I forgot the negative right here. See, 64 divided by negative 8 is a negative 8 over x. Here, a negative in front of a negative gives you a positive 8 over x. If you go to the other side, notice choice B. All right, 3x plus 3 plus 8 over x is the right answer for this one right there. Okay, so here's number 25. Notice you're taking a binomial and multiplying it by a trinomial. Distributive, 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 folks. That's what you got to keep in mind. You're using the distributive property here. First, you distribute the 8p, which means you multiply it against all 3 terms in the other factor, which is the trinomial. Then, you're going to distribute the negative 1, which means you multiply it by all 3 terms in the other factor, which is a trinomial. So that's 6 multiplications, and then in the end, we'll clean up by looking for any like terms. All right? So right off the bat, you got 8p times 64p squared. So 64 times 8, you can go off on the side of your paper and do that since you don't have a calculator. 8 times 4 is 32. 8 times 6 is 48 plus 3 is 51. So it's 512. And it's p times p squared, so that's p to the 3rd. Then you have 8p times 8p, that's a positive, 64 4p squared. Finally, for the 8p, 8p times 1. That's easy, right? Just 8p. Now we distribute the negative 1. Notice, and remember, when you multiply by a negative 1, the only thing that happens is signs change, right? So positive 64p squared becomes negative 64p squared. And you can already see what's going to happen here, right? When we combine like terms, these are going to cancel each other out. They're opposites, okay? For the next one, you got negative 1 times 8p. That's a negative 8p. Look what's going to happen to the term 8p. That's going to cancel out. Positive and negative 8p, they cancel each other out. Finally, you got negative 1 times a positive 1. That's a negative 1. And then we just combine whatever terms remain, which are only the first and last term. If you see it here, you got 512. Hold on a second. 512p to the third minus 1. These two middle terms cancel out. And take a look at what you have here. You actually have a difference of 2 cubes here. Okay, you have a difference of 2 cubes, whether you knew it or not. All right, and this is how it would factor out right here. So we go over to the other side. You got 512p to the third minus 1. There's your final answer, choice C. Be careful because A looks very similar. You don't want to make a mistake there. By the way, if you came over to me at the end of the test and you answered A and you told me you just did it by accident, I'm not going to give you credit for that. All right, that's a human error, but that's not really a slip of a pencil or anything. That's just you not paying as close attention as you should, or maybe you really thought it was plus. All right, it's a very subtle difference, but a very distinctive one too. It's choice C, and only choice C for that one. Okay, folks, yet again another system problem. This must be the fifth one, sixth. I don't know. I've lost count now. But it says, again, solve by the elimination method. It's your choice. I think this example lends itself maybe a little bit better to the elimination method. Remember what the elimination method says. When you add the equations together, meaning add the like terms together, you want to eliminate either the x's or the y's, meaning the x's or the y's, their coefficients must be opposites. Now, that's not the case with either the x or the y right now. But notice if you took just that first equation and did a slight augmentation to that, meaning you multiplied it through. Let me see, make sure I copied this right. Yes, I did. Multiplied it through by a negative 2. Notice what you would get. Negative 2 times a 4x would give you negative 8x. And of course, when added to positive 8x, they cancel out. But you have to remember that if you're going to multiply through, you have to go all the way through. Not just the first term, you got to multiply all three. So we're going to end up with a new first equation when I multiply it through by a negative 2. Negative 2 times 6y gives you a negative 12y, and negative 2 times 15 gives you a negative 30. Now we can add our equations together, and you can see what happens. Exactly what we wanted to happen. The x's cancel out. But also notice what else happens. The y's also cancel out. They're opposites, 12y and negative 12y. In addition to that, the constants cancel each other out. So here's what you're left with. You have 0 on the left-hand side of the equation and 0 on the right-hand side of the equation. That, of course, is an identity. That's a true statement. 0 does, in fact, equal 0. When that happens, when you eliminate either one or both of the variables and you end up with a true statement, okay, that means you have infinite number of solutions. Now, for a system, you remember what that means. Okay, it's over here, so you have infinite solutions. That means you have coincidental lines. One line lying right on top of the other, like looking down over I-95 with Richmond Street run underneath it, looking down on top of a certain part of the elevated train with Front Street right underneath it. Okay, coincidental lines. One point on one line is also the same point on the other line. Alright, so in terms of your answer here, notice you're going to go with part C, infinite number of solutions for your choice, and on to the next problem. Okay, here's number 27. Notice it just says solve, and you have an equation, and that's exactly what you can do. We need to end up with an answer for t. Notice, folks, that t is squared. That should indicate immediately to you that you have the potential for two possible answers for t in the end here. Alright, and that's exactly what's going to happen. Notice when you want to solve a quadratic, you need two things. 0 on one side and the other side factored. So you have the 0, but the other side of the equation is not factored yet. There's no GCF I can take here, but I can try or attempt to factor it into two binomials. That'll be t times t. This positive in front of the constant tells us that the signs are the same, either both positive or both negative. Which one it's going to be is determined by the sign in front of the linear term, which is a negative, so they both become negative. Finally, the numbers that go here have to be factors of 45, and those same two numbers have to add up to a negative 14. About a negative 9 times a negative 5. That does indeed give us a positive 45, and when you add negative 9 and negative 5, you do get negative 14. Now, you're not done. Once you have your factors, take each one. This is why you have to have 0 on the other side. Take each one and set them equal to 0 and solve. If you add 9 to both sides, and then add 5 to both sides, and you end up with two solutions here, neither of which are extraneous, meaning you have no denominators up here that would become 0. You have no even indexed radicals up here that would become negative underneath. Nothing to worry about. Your two solutions are 9 and 5. Now, be careful here. Very, very careful. When you enter your answer, do not enter the number 95, meaning don't enter 95 or 59. You have to use a comma, and they're trying to help you out. It's programmed to accept 9, 5 or 5, 9. It won't accept 95 or 59 because that's you telling the computer that your solution is just one and it's either 95 or 59. And of course, don't answer both of those because it's not 95, it's not 59. The solutions are 9 and 5. You've got to enter them with a comma. You don't need parentheses here because you're not entering the coordinates of a point. All right, or an interval, or giving an interval. You're just giving the two solutions, 9, 5, or 5, 9. Don't answer it any other way if you get this problem on the final. Okay, number 28, factor completely. Notice this time, no equation, so the directions don't tell you to solve for a because you can't. We don't have an equal sign, so we can't say what a is. They just want you to take the expression and factor it. Now, there's no GCF to take here, all right? There's no trinomial. You have to recognize this is a difference of two squares. And remember, whenever you're factoring, and they try to help you a little bit, see the word right there? Factor completely. It's understood that you have to make sure you factor completely. So that's a difference of two squares. This is a subtraction, which means a difference. This is 4 times 4, and this is a squared times a squared. So let's factor it like a difference of two squares. There's a plus and there's a minus. Got a squared plus 4 and a squared minus 4. Factor completely. Factor completely. Look at this factor right here, folks. That can be factored again. This one cannot. The first one cannot. But this one is also a difference of two squares. So you have to factor it again. It's not going to accept the answer if you just type this in. It won't take it. And you cannot forget this first factor. All right, it won't take the answer if it won't accept the right answer if you leave this factor out in the end. So we're going to take that second factor, a squared minus 4, and factor it again. That's a times a and 2 times 2. And you have to type it just like that with parentheses, with nothing in between the parentheses, no commas, no pluses, no minuses, because when there's nothing there, it's understood to be multiplication. That's what you're going to hit point or radio button A. Put your cursor in there and type exactly what you have over here, parenthesis a to the second power, so you got to use that little radio button, right? Where's it at? Right here, you got to use that little radio button there to enter the squared. That's the only one you got to enter. It's the only exponent. Okay, you have to make sure you enter correctly with these. This is where practice beforehand really helps out. Meaning practicing before you take the final with this program. Okay, number 29, you just had a problem like this on your third test. Okay, notice you've got one fraction on either side of the equation. You can treat this as a proportion, meaning you can cross multiply if you want. That's one way to do it. All right, or you can look at this the same way you were doing any of the other problems, get a common denominator. That might be the easier way to go with this one. Notice if you just took this fraction over here and multiplied top and bottom by 2, you would have 2 times 7, which is 14, and you'd have the exact same denominator as this fraction. Okay, that's one way to do it. You distribute through with the 2, so you have 2 times 21, which is 42, and then 2 times a negative x, which is negative 2x, equals x. Since your denominators are the same, you don't need the denominators anymore. Just solve this for x. So notice you've got x on both sides. So let's add 2x to both sides. That way we have our x's on one side of the equation. That leaves you with 42 equals 3x. Divide both sides by 3. 3's cancel out, of course. And if you think about your times tables, 3 times 12 gives you 36. 42 is 6 more than 36. That's 2 more 3's. So you'd end up with an answer of 14 for x. Now, if you did decide to do it the first way I mentioned with a proportion, you would, again, what you would do is cross multiply, okay? Cross multiply. You'd have 7 times x equals 14 times 21 minus x. Okay? There's one side. These are cross products, folks. The product of the means equals the product of the extremes. On the other side, you'd have 14 times 21 minus x. A little bit bigger numbers over here, okay, because you have to distribute this 14 first. And 21 times 14, you can do that off on the side of your scrap paper somewhere. 4 times 1, 4 times 2, add a 0. 1 times 1, 1 times 2, add them up. And you end up with 294. And then 14 times a negative x is negative 14x. Get all your x's on one side. So I'm going to add 14x to both sides. That gives me 21x over here on the left. Equals 294. And finally, divide both sides by 21. We already know the answer is going to be 14, but let's prove it. So we have to divide 21 into 294. We fit 121 inside of 29. Gives us a remainder of 8. And then we fit 4 21s exactly into 84, remainder of 0. Okay, so that's why I said this way, for this particular example, worked out easier, because you didn't have to do any of this extra arithmetic, really. Okay, that was kind of taken care of for you. This is the biggest operation you did over here, 42 divided by 3. But either way you do it, you get the same answer of 14. Okay, so this one, just type in the box 14. That's a pretty straightforward one there. All right, number 30. We're approaching the end of the test. I think I'll be able to get everything in on this video. It's about 42 minutes right now. I think we should be okay. Let's see. All right, so look, folks, this is one we just did in class last night on Wednesday night of this week here. Simplifying radicals from Chapter 7 in your book. Remember, simplify, you want to factor it like you would your prime factorization. So you think of two factors that equal 360. How about 10 times 36? Okay. Right off the bat, the square root of 36 simplifies just the number 6. You could attempt to factor the root of 10, or the square root of 10. Whoops, hold on. You could do that, but that's as far as you're going to go. So it depends on what the programmer will accept as an answer. If you write this as the final answer, and I don't think this is multiple choice. No, it is multiple choice. Okay, good. That kind of leaves no doubt. You have to realize that if you arrive at this and think it's your final answer, then you get over here and you don't see it, you've got to realize that these two mean exactly the same thing. Don't forget your negative as well. If you look, that's example or choice B right here. 6 times the root of 10. There it is. That's the final answer for B. Or for this problem here, it is B. Okay, here is number 31. Very straightforward. Find the product. You're just distributing these two factors together, these two binomials, FOIL, if you will. All right, so first we're going to distribute the 11p. Then we'll distribute the positive 6. And we'll combine like terms if we can. So 11 times 11 and p times p. And then 11p times a negative 6 is a negative 66p. Now we distribute the 6. First one is 6 times 11p. That's a positive 66p. You can already see these two middle terms are going to cancel each other out to 0. Finally, the last multiplication or distribution is 6 times negative 6, which is negative 36. And here's your final answer. Again, make sure you know how to enter enter your final answer here using the square root, or I'm sorry, using the square key. Oh, in fact, you don't have to in this one. That's an easy one. 121p squared minus 36. Yep, there's the final answer right there, choice C. Okay, here's number 32. Write the expression in lowest terms. Remember what that means. You're simplifying a fraction. Do not multiply these two binomials across the top, and do not multiply these binomials down here. The work's already done for you. They just want you to cancel common factors. The main thing that this problem wants you to make sure you realize is that you have two factors of m plus 6 down the bottom. So if you wanted to, you could take out that 2, right? Scratch it off if you want, and put another factor of m plus 6 down there. Okay, that's what it really means. I'll just cancel any common factors top and bottom. Notice you've got an m plus 6 up top and m plus 6 down the bottom. And that's it. That's it. There's no other common factors. You cannot cancel the m's. You cannot cancel the 6's. Okay? There's what's left up top, a factor of m minus 6. There's what's left down the bottom, a factor of m plus 6. You cannot cancel these. We just talked about that in class last night too. Cannot cancel the 6's. That's it. There's your final answer. Now this one is not a multiple choice, okay, so you have to use your fraction button here, right? You have to punch that button, and in the numerator type m minus 6, and then put your cursor in the denominator and type m plus 6. Okay, number 33, solve. Why do you want to solve? Because you were given an equation. That's the only time you can solve, so we got to figure out what x is in the end. A little tip right here, this little square probably means you're going to end up with two answers possible, and three of your choices have two answers, don't they? Let's see. All right. Now, remember what you need to do to solve a quadratic. There's two rules you have to remember. You have to have 0 on one side, and you have to have the other side factored. This left side is currently factored, but the problem is I can't just bring this 4 over, and I can't just combine it with the negative 6. By order of operations, I'd have to distribute first. I'd have to multiply these two binomials together first before I could do that. Just like the last problem, here's what x minus 6 squared means. You have two factors of it, right? So multiply these together, x times x, then negative 6 times x, and then in the inner terms, negative 6 times x, and then finally negative 6 times negative 6, which is a positive 36. Okay, you've got some like terms here. Combine them together to give you negative 12x. Now, and only now, can you bring over your 4 by subtracting it from both sides. So you notice if you brought it over right off the bat, you'd be subtracting 4 from negative 6, which is wrong. Really, that ends up being a positive 36. Okay, that's where you got to be careful. Now you've got 0 over here, and now you have a trinomial that you can now factor. And because it's a different trinomial, right, 36 minus 4, it's not going to come out the same way it was up here. Now you've got to factor this trinomial. You've got 0 on one side. We now need to factor this trinomial, x times x. The signs will be the same. They're both going to be negative. Factors of 32 that add up to 12. How about 8 times 4? Right? That works. Negative 8, negative 4 adds the negative 12. You multiply them, you get 32. Always remember, you're not done until you set both factors equal to 0 and solve, and you end up with positive 8 and a positive 4. Again, this was a multiple choice. Okay. Notice D is the only correct choice there. D is the only correct choice for this one right now. Okay, number 34 here. Notice, folks, it says perform the indicated operation. You're adding, which means you're just combining like terms. So look what I wrote on the whiteboard. I wrote the same problem without the parentheses. Because there's a plus sitting there in the middle, all right, you really don't need the parentheses. The only time the parentheses are important is if you had a negative sitting in front, which you'd have to first distribute to change the signs of everything in the parentheses after. But that's a plus. I can just remove the parentheses. And all I'm going to do now is simply add like terms. So start with this one. Doesn't matter where you start. That's a constant. I'm going to look for all constants here. And there's only one other term that's also a constant. I'm going to put them together. Negative 3 and a positive 5 gives me 2. and they're done. Next term is an n to the 7th. I have 8 of them. And there's one other term that's alike with that. So I'm going to add the coefficients only, right? You're not adding the term. It's going to be something n to the 7th when you're done. And it's going to end up being positive 14, 8 plus 6. All right, so those are done. And there's only 2 terms left, and they happen to be alike. They're both n to the 5th. 5 of them, 7 of them. So in the end, when you put those 2 piles together, you have 12 of them. And there's your final answer. Now realize, before we go over, I think this is multiple choice. It is, okay? The multiple choice can give these terms in any order they want because of the associative property of addition. They can be given in any order. Let's see. Looks like choice B went ahead and gave you the 3 terms, 14n to the 7th plus 12n to the 5th plus 2, and they gave it to you in descending order. But you have to realize that you have it right there. Same exact thing, just in a different order. This 2 was put after it. Plus 2 is down here, right? 14n to the 7th plus 12n to the 5th plus 2. Choice B is your answer right there. Okay, this video is getting kind of long, but we only have 2 problems left, so I might as well squeeze them in. The length of a rectangle is 6 inches more than its width. If 3 inches are taken from the length and added to the width, the figure becomes a square with an area of 400 square inches. What are the dimensions of the original figure? All right, so we start out with the length of a rectangle having 6 inches more than its width. Excuse me. And then we take 3 inches from the length and add it to the width, and we end up with a resulting figure of a square with an area of 400 square inches. 400 square inches on the square. So let's draw a little square real quick. All right. It tells us that in the end, the area for this guy is 400 square inches. Okay? Remember how you get area for a square? You take a side and you multiply it by itself. Now let's think about this. The rectangle starts off as a rectangle with 6 inches, the length being 6 inches more than the width. Okay. Then we take 3 inches from that length and we add it to the width. And then the figure becomes a square. All right. Hold on 1 second here. All right, so let's see. Let's toggle back over. Let's draw a rectangle as well. This is what we really start with here. It says if, let's go back and read it. The length of the rectangle is 6 inches more than its width. Okay, rectangle with a length 6 inches more than its width. So let's say this is the width right here. It doesn't matter which one we label. That's the width. Then the length would have to be 6 inches more than that. X plus 6, whatever the width is. Okay. The next sentence says, if 3 inches are taken away from the length and added to the width. So I'm going to take 3 away from this. So what I would do is subtract 3 from it and then add 3 to the width. So we take 3 inches away from the length. Here it is. If 3 inches are taken away from the length, which is currently x plus 6, now it becomes x plus 6 minus 3. And you add it to the width, which starts out as x, and you add 3 to it, so it becomes x plus 3. You end up with a square. How do you know? Well, when you subtract 3 from this guy down here, doesn't it now become x plus 3, just by combining those 2 like terms together? And if you have the same length and the same width, guess what you have? A square. Okay? So now the problem is, it becomes a square, and they give you the area of that resulting square. What are the dimensions of the original figure? You know the dimensions of the original figure were x plus 6 by x. There's the dimensions of the original figure. If we know what x is, right, if we can figure out what x is, then we'll know the answer. We can plug it into both of these and have the original dimensions. So how do we figure it out? Well, we know that for the square, one length of one side, all 4 sides, in fact, because that's the way a square works, right? X plus 3 all the way around. The formula for the area of a square, or any rectangle for that matter, because a square is a rectangle, is to take a side and square it. Multiply it by itself. That's going to give you 400. So we got to solve this one here. First we distribute. We get x squared plus 3x plus 3x plus 9. Going a little bit quick here with this because of the video being so long in length. Okay. Now remember, just like the last problem we did a few problems ago, you've got to get 0 on one side, so I'm going to subtract 400 from both sides. And you end up with x squared plus 3x. I'm sorry, that's actually 6x. We combine those two terms there. There we go, combined like terms. And you have a negative 400 plus 9, which is a negative 391 equals 0. So we've got to think of some factors of 391, a little bit challenging here, right, that are going to give you, excuse me, that are going to give you a 6 when you add them together. So again, we have no calculator, so you've got to do your best here. This is a bit of a challenging problem, a little bit time consuming. I would hope you would save this one for last if you had to. Okay. The only thing you can really do is just, I'd say that a tip for doing something like this without a calculator is to think of numbers that would add up to 6. And you're going to have to try to test it by dividing whatever number you come up with to see if it's a factor for 391. You know, maybe 12. See if 12 goes into 391. And that's an odd number, so 12 doesn't go into any odd numbers off the top of my head. Maybe 13 is a possibility. And you'd say, okay, it would have to be 13 times a negative 7. Realize the numbers you pick have to have different signs, so they subtract out to give you a positive 6. And the bigger number has to be positive. So maybe 13 times negative 7. Now that doesn't work. How about if you divide 391 by 17? Let's see how that works. All right, 17 goes into 39 twice. 2 times 17 is 34. That gives you a difference of 5. Bring down the 1. And 17 does go into 51 evenly. So that means when you end up with no remainder, that shows you that 17 is a factor of 391, meaning 391 is divisible by 17. And look at your numbers, 17 and 23, with different signs. If you take a 23 and subtract 17, guess what you get? Positive 6. So here your solutions are going to end up being negative 23 and positive 17. Now, next. How can you have two different answers for x when there can only be one? Remember what we're dealing with here, folks. We're dealing with distances. Remember absolute value? Remember I gave you the example of me traveling from Philadelphia to North Carolina and back? Neither distance is negative, so you cannot have a negative distance. So x cannot be a negative 23. It's impossible. Okay? Therefore, the only possible solution is 17. So the dimensions of the original rectangle are 17 plus 6, which is 23, and 17. So the original dimensions were 23 by 17. I believe this was an open-ended question. No, it's multiple choice, so that might help you a little bit too. You can actually, since it's multiple choice, I didn't realize it was. That could save you some time. You could check all these answers to see if when you square, you play with these by subtracting 3 and adding 3 to the other and see if you get 400. You've got to be a little savvy with that, but notice, folks, it's choice C here for the answer. Okay, final problem here. Use a combination of rules for exponents to simplify. Remember, there's no order of operations here. Final multiple choice problem 2. Write your answers with only positive exponents. Okay, so here it is. Notice, again, there's no order of operations. What I would say to do first, it's up to you. You can take this p to the negative 3, bring it down. This factor of 2, bring it up. It's up to you. But for me, I always think of getting rid of this exponent sitting outside first. Remember what this means. This 2 belongs to the 2 here as a base, the p, the q, the 2, the m. All 5 of those factors have that 2 as an exponent. So for this 2 right here, that's an exponent of 1. Power to a power means you multiply, right? 1 times 2. For the p, you have negative 3 times 2. So negative 6. For the q, even though you don't see it, right, it's got an exponent of 1, so it's 1 times 2. Down in the denominator, you've got negative 1 raised to the second power, so it's negative 1 times 2. And for the m, you've got 3 raised to the second power, so it's 3 times 2. Okay? So however you want to handle this now, you could say, all right, well, I got a 4 sitting up top. 2 squared is 4. Or I could look at it this way. I've got a common base, and when you're dividing, as we are here, you can take the top exponent minus the bottom exponent. 2 minus the bottom exponent of negative 2. For the p, there's no other p factor in the denominator, so I'm just going to go ahead and take this p to the negative 6 and bring it down to the denominator and make the 6 a positive 6. Okay. The q squared, that's fine where it is. I've got nothing down in the denominator to cancel that with. And the m to the 6, that's fine where it is. I've got no m factor up top to clean that up with. The only thing really left here is to take care of this negative in front of a negative, which is always a positive. So 2 plus 2 is 4. So you end up with this. 2 to the 4th q squared divided by p to the 6th m to the 6th. So the only thing left that you can do here is take that 2 to the 4th, which is 2 times 2 times 2 times 2, and make it a 16. Q squared over p to the 6th, m to the 6th. Okay? And that's it. I only need the equal sign because we're done. Now let's go over back and see which one that is. 16p squared over p to the 6, m to the 6. I believe that's the right one, right? Yep, p6, m6, 16q squared. Choice A is your final answer there. Okay? All right, folks. Good luck. If I can do it again, I'll do a fresh new test and do 36 more problems. We'll see. Good luck to you.